So here's a review of exponential functions. Sorry, here's a review. So back in Math 1, you learned that the exponential form for a function is a times b to the x. And you learned some basics. You learned that a was the starting value, aka the y-intercept in an untransformed function, and that b indicated your growth or decay for that function. So for example, if I have y equals 3 times 1.3 to the x, I can expect the y-intercept to be 3, right? And I can expect for it to be growing, all right? You can see that the blue function is growing, while a function like 5 times 0.74x is going to have a y-intercept at 5, all right? And is going to decrease, all right? It's going to decay. We call that exponential decay, all right? So one of the main questions that you're going to be asked about this is, okay, so the y-intercept is pretty simple to tell, that starting value, right? Because you evaluate the function at 0, all right? Think of it. If you evaluate your b value at 0, anything to the 0 power is 1, so that just leaves you with your y-intercept, okay? So the y-intercept is not usually the bulk of our studies. The bulk of our studies is usually, let's interpret that b value. So what does 1.3 literally mean? So 1.3 indicates growth. And the reason that it indicates growth is that it has a difference of 0.3 from the value 1, all right? So to find the growth or the decay, take your b value and find its difference from the value 1, all right? For example, 1.3 minus 1 is 0.3, meaning that we have a 30% growth in the blue function, all right? And the green function, we have our b value of 0.74. Its difference from 1 is 0.26. That difference, however, is a decrease, right? So this function is losing 26%. In other words, it's decaying 26%. Regardless, your b value is a clue as far as how much are you decaying or growing, okay? So that's how the b value works, okay? Now, there are more complex examples of this. So we can have much more intricate examples. So here's an example with actually something called compound interest. If I have 1,800 times 1 plus 0.078 divided by 4 raised to the 4x power, that's a little more complex. Okay, so first of all, you're going to have to do some simplifying because you want to get this function back into y equals a times b to the x. So you can simplify your what's inside of your parentheses, that's order of operations, and you end up finding that the decimal inside of parentheses is going to be 1.0195, meaning that we see growth. This is going to be a function that grows, probably, all right? The tricky part is this function is actually not growing by 1.95%, all right? So in this case, that's still not a b value. It's not a b value because your exponent is not x. Your exponent right here is 4x, meaning that 4x indicates that you're compounding. For example, if normally these are functions of time, a 4x would mean that you're compounding 4 times a year, right? In other words, once every 3 months. So you could say 1.95% every 3 months, but we're really looking for yearly. So what you're going to have to do for in these cases is think of your exponential properties. 4x is really the product of 4 and x, which if you reverse the product property of exponential functions, you can think of that b value as 1.0195 to the 4th power, all right? And that is an equivalent function right there. So that decimal to the 4th power actually is 1.08, all right, with a few more decimals. Now it's in y equals a times b to the x. That reveals that the actual growth of this function is roughly 8%, all right? So hopefully that helps. Okay. Again, we used one of our exponential properties called the product property, which you learned actually back in the 8th grade. Okay. Now, evaluating exponential functions. Last thing I'm going to say is these functions work like any other function. All right. You can take an input, substitute it. Just be careful with your order of operations. So for order of operations, I would carry out any operations that exist in the exponent. Then I always raise the b value to the exponent, find that number, and finally, at the end, multiply by your a value. So that's how order of operation works.